right, 12.3, solve multi-step problems involving measurement units. Now, the I can statement actually gives us a clue about what you'll need to do to solve these problems. So it says, I can solve multi-step problems by identifying and answering a hidden question and using that answer to solve the initial problem. And I realized that's really the key with multi-step problems is figuring out that in-between thing we have to figure out, right? Because we can't just go from what they give us to the answer. We have to go from what they give us to something in the middle to the answer, and we have to figure out what that middle thing is. So I put the word problem protocol on your sheet to help remind you of the steps we can go through, right? So we can read the problem one sentence at a time, make sure we understand the story, reread it if we need to, which probably we will, make a plan, how we're going to solve it, draw some sort of picture or representation, carry out the plan, and then check that our answer makes sense. So we can look for keywords, number words, make sure the math operation matches the story, taking our time, all those good things. So the problem we'll do as an example says Annie's mother needs to have enough water to fill 16 water bottles. So like a bottle of water. Each bottle holds 475 milliliters of water. Which water jug should Annie's mother use? So essentially is 7.5 liters or is 9 liters the right amount if she needs 16 water bottles that each have 475 milliliters of water? Okay, so we need to convert units of measurement, right? If we have milliliters, but then we also have liters, we're going to have to do some converting. So in your notes, go ahead and write, to solve some problems, you need to convert to CONVERT units of measurement. And if you have smaller handwriting than me, then you can fit it all in one line. But on my screen, I do not have small handwriting. All right. So the first thing we need to do is figure out how much water she needs for those 16 water bottles, right? Nowhere it says like how much water does she need, but we do need to know how much water that is. So imagine I have 16 bottles, right? Like there's a bottle. I know those don't look like bottles, but each one is 475. So then how can I find the total for all 16? Well, I can multiply because I'm repeating 475 16 times. So we know we need 7,600 milliliters, right? So that's 7,600. We're still in milliliters because that's what the 475 was in. All right. We can multiply, which we did, right? We're repeating that 475 16 times. There's another way I could draw a picture of it. I drew some bottles. You could also think of it in terms of just like a bar model. Once we do it, 7,600. But now we need to figure out what that is in liters because those jugs were in liters, right? So we know 1 liter is 1,000 milliliters. Remember, if we flip back to your chart from 12.2, so going from little milliliters to bigger liters, we need to divide. So we're dividing by 1,000. Oh, calculator, there we go. Divided by 1,000. So 7.6 liters is how many liters of water Annie's mom needs. Right, 7.6. So Annie's mother needs 7.6. She would need to use the bigger one because the 7.5 isn't big enough. She needs more water than that. So that middle thing, we had to convert, and also figuring out, oh, I needed to figure out how much water she needed was sort of that middle mystery step. So I'm going to have you try, but if you look at the problem, give it a try, and are confused, just click and have me explain it. Like, don't spend forever ever trying these if you're confused. Let me explain it, see if that helps. Then on your worksheet, you can get more help with it, okay? Remember, you can use a calculator. Adrian has a roll of wrapping paper that is 3 yards long. He uses 1/3 of the wrapping paper to wrap a present. What is the length in feet of the paper left on the roll? Did you get it? All right, hopefully you gave it a shot and then took a guess if you weren't sure. So, notice it tells us what he uses, but then it asks what's left. So we have to sort of think, okay, let's figure out what he uses, and then we can subtract to figure out what's left. So if it's 3 yards what he has, he uses 1/3. Well, what's 1/3 of 3? If I have 3, I need to split it into 3 groups to figure out 1/3. It's just 1, 1, and 1, right? Each foot is 1/3 because that's 3 equal groups. Remember, we're in yards right now. So if he uses 1/3, he has 2/3 left. So he has 2 yards left, but it asks us what is the length in feet. So now we need to go from 2 yards to a certain, figure out how many feet that is. Well, again, if you flip back to your first page, 1 yard is 3 feet. And I would need to multiply because I'm going from something bigger to smaller. So 2 times 3 equals 6 feet. Okay. Now I could have said, well, he uses 1/3, he uses 1 yard, he uses 3 feet. I know that 3 yards is 9 feet, so 9 minus 3 is 6. So kind of depending on which way I want to think about it, either way would work. But there was that middle, like, well, how much did he use in yards? How much is left in yards? And how much is left in feet? Ruby's backpack has a mass of 4 kilograms. She removes a book that has a mass of 120 grams. What is the mass of Ruby's backpack after she removes the book? All right, hope you got it. Now notice how we start with kilograms and our answers are in kilograms. So that makes me think, let's change this 120 grams to kilograms first, and then we can use it in our problem. Because if I change this to grams, then I'll just have to go back to kilograms anyway. It'd actually end up converting twice. And I know that 1 kilogram is 1,000 grams. You can use your chart to help you with that because it's 3 jumps away. So I know 120 grams. I'm going to need to divide by 1,000 because we're going from something smaller to bigger. So if I take 120 divided by 1,000, I know that her book is 0 and 12 hundredths kilograms. So now we need to take her 4 kilograms, subtract the 12 hundredths because she took it out. 4 minus 12 hundredths and get 3 and 88 hundredths as our answer. Now, even if hopefully you could eliminate that one because there's no way that I could go from 4 kilograms to 38 kilograms if I took something out. So that's where using some reasoning can help us narrow down our choices sometimes. All right, let's do a few more. Okay, this one I want to show you because we haven't done a lot with fractions, but I think I think you'll be able to get it if you just sort of follow along. So, Amy's family has 2 gallons of milk in the refrigerator. At dinner, her family drinks 3/8 of the milk in the refrigerator. How many cups of milk are left? Well, notice I have gallons and cups. Now, I could figure out 3/8 of 2, but that's going to be a weird fraction. So I think I'd rather change it to gallons or 2 cups first, and then I can deal with the fraction part of it. So remember, if I think about my gallon, 4 quarts. In each quart, there's 2 pints. In each pint, there's 2 cups. So each quart is 4 cups. So that's 4, 4, 4, and 4. So I know that 1 gallon is 16 cups. So then 2 gallons is going to be 32 cups. Now, I need to figure out what's 3/8 of 32. Well, if I want to figure out 1/8, I can think about taking this 32 and I'm dividing it into 8 equal pieces. How would I do that? Well, divided by 8 and I'd get 4. So each 1/8 is 4 cups. But they drink 3/8 of them, so they drink these ones. So then these 5/8 are the one that's left. 4, 4, 4, 4, 4. 5 fours is 20 cups. If you didn't totally follow that, it's okay. But I just want to know that, or want to show you, even though we haven't really done this multiplying with fractions bit, I can figure out 1/8 or 1/4 or 1/3 by dividing it into that many pieces. And then I can just multiply by how many pieces I need. All right, one more. And then again, if you need help, no problem. A track at the school is 400 meters long. Jackson walks around the track 3.5 times. How many kilometers did Jackson walk? All right, give it a try. All right, hopefully you got it, or at least gave it a good shot, engaged that brain. Let's just say if it's 400 meters and he walks around it 3 times. Well, that's 400, 400, 400, right? So 3 400 is going to be 1,200. Another half a time, well, half of 400 is 200. So I know he went 1,400 meters. This is when we got to pay a lot of attention to the unit. So then how many kilometers is 1,400 meters? Well, if you look back at your chart, we know 1,000 kilometers, or 1,000 meters is 1 kilometer, and we're going from smaller to bigger, so we need to divide 1,400 divided by 1,000, I will tell you, is going to be 1.4. Or I can take this decimal and move it over 3 times. Same thing, like on my chart. 3 jumps, 3 spots for the decimal. 1 4/10 kilometers. All right? Good luck on your practice. If you need help, don't hesitate to ask. Good luck.